Hi there. Welcome to physics. So the first thing that we need to understand when we approach the topic of physics, or really any other science, is we need to understand what science is in the first place. And unfortunately, this is science in general is very commonly misunderstood by both students of science as well as teachers, sadly. I've come across many teachers that show that they clearly don't quite understand exactly what science is and what it isn't. And to be honest with you, I've taught things wrong about science and have had to be corrected myself. We need to understand exactly what science is. When we approach science, we need to understand how it has developed, what kinds of questions it answers, and we need to understand what it is and what it is not. If we don't understand those things, unfortunately, we can very easily misunderstand the things that we learn in science or the things that scientists try to communicate to us. And I don't want that for anyone. So let's go ahead and dive in and talk about science as a whole. Let's take this example first. Let's imagine that you're out in the snow and you see these tracks. And the question would be, based on what you see, what do you think happened here? And so you can formulate your own hypotheses for why that would happen. It's a good scientific word to use. Perhaps you might say that there are two animals walking along. One is a smaller animal. Perhaps it's a rabbit. This is a larger animal. Maybe this was, let's say this is prehistoric times. Let's say this is a big T-Rex and this is a, I don't know, velociraptor, something like that. But we can't really see anything else from this. All we see is tracks. We can't even assume the timing of these. We can't assume that these tracks were made at the same time. We don't know really what happened. We have limited information. Well, if we increase the amount of information we have, does the new information now change our story? So look at the way the picture has changed, and it looks like all of these tracks converge in one place. That's an observation that we make, and they're all mixed together. Could be coincidence, could be not a coincidence. Notice the bigger ones' tracks start to speed up, as do the smaller ones, looks like. So what would we say happened now? What does it look like? Do we have a little bit more information to be able to conclude something about the timing of this event? What do you think is going on? Okay, and then what if we even add more information? Well, now the picture becomes a little bit clearer as to what has happened. You know, perhaps the larger animal, perhaps there was a fight here, something happened. Perhaps there was a predation event. Maybe the smaller animal stayed behind because it was killed. Maybe the larger animal ate the smaller animal. But we clearly don't see the smaller animal's tracks here. Maybe they stayed behind. So all we're doing here is we're looking at the information we have and we're coming up with a reasonable explanation for what we think happened. And that'll help us to inform what we're going to talk about for the rest of this topic. It's useful to understand that there are observations that's simply describing what we see. There are things that we can infer from this. There are certain things we can infer from, for instance, the length between the footprints. Certain things we can infer from the fact that there are no small footprints here. But there's a difference between an observation and an inference. And it's also useful to understand that we do have some limitations. Just with this limited information, we cannot completely conclude exactly what happens because the footprints is the only information we have. We don't have any video footage. We don't have any measurements of anything else. There are no plants in the picture. There's no grass in the picture. We can't see any of that stuff. There's absolutely nothing else. So we're extremely limited in the information we have in order to draw conclusions from this. So this leads us to talking about science. So if I just ask you the question, what is science? There could be a lot of different answers to that question, and I really want you to know about three of them. First of all, we need to know that science is a process. It is a process that helps us learn about, well, that's a good question. What is science about? Well, we need to understand that science is a process that helps us learn about the natural world, the natural universe. Helps us learn about nature. In other words, anything that we can understand with our five senses, anything that we can see, hear, feel, taste, or touch, those things are the things that we can focus on in science. Those are all natural. They are physical. It's very important to understand that, and we're going to talk about what science is not here in a minute. So science is, first of all, a process. It's a process that we go through to help us learn about what our observations are. And in a small way, we kind of went through that process in this small example here. The second thing I want you to know is science is a way to answer questions, a way to solve problems. We have a lot of problems in our world. We have cancer, we have environmental problems. We have questions as to why things are happening. Well, we can use science to answer a lot of those questions and to solve a lot of those problems. And it's important to understand that science is specifically a way to answer those questions that has a strong philosophical underpinning. In other words, there's a way to answer questions and solve problems that is not science. Science is not the only way to do things, but science specifically has a very strong philosophical underpinning. We are building on the philosophies and the discoveries that have been before us in order to use science. And the third definition of science that I want you to know is that, yes, it is a body of knowledge that currently exists as a result of this process that I talked about. Now, the third definition is probably the one that most people will say. When you say you are going to science class, you're going to learn science, more than likely you don't think about understanding the process. You just think about memorizing the facts, the body of knowledge that now exists. But it's understanding, let me back up. It's important that we understand that that knowledge came about because of this process. Nothing ended up in your science textbook just by somebody simply writing it there. There was a long process that had to take place in order for that to occur. So this is what science is. It also helps us to understand science if we understand what science is not. So several things you need to know that science is not. First of all, science is not unlimited. We cannot use science to answer every single question. I told you before that science is about the natural world, about the physical universe. In other words, we cannot use science to answer questions about the supernatural world or the metaphysical world. Now, this doesn't mean that those things don't exist, and I think it's sad that there are a lot of scientists who do think that way, and they think that science can be used to answer every question. Therefore, if you cannot prove something with science, it must not exist. And I want you to know that's not the case. An important extension of this that's very, very famous, a long ongoing debate, is whether there is a God or whether there is a supernatural being. It's important to understand that that's an important question for us to consider. It's also important for us to understand that science really can't be very useful to us in answering that question. Because if there is a supernatural being, if there is a God, he is metaphysical. He is not physical. Whatever your concept is. So it's important that you understand that we can't use science to answer every single question. And there are many things that we experience in life that fall outside of our five physical senses. We can feel love, we can feel sadness, we can feel emotions, we can feel anger. But it's hard to fit those emotions into one of those five senses. They're a combination of all of them. So it's important to understand that science is not unlimited, and that's okay. Science is not king. We really need to understand that point. Second thing science is not, is it is not perfect, and this is kind of along the same lines. Science is not infallible. That is a word that you need to know. Every single theory in science, by definition, can at least be improved, if not completely proven wrong. So you need to understand this picture right here is good. Science is incomplete. Science is not perfect, and there's a part in your notes under there that says no P word. We don't use the P word in science, and that P word is prove. In science, we do not prove anything. We can support hypotheses, We can prove that hypotheses are wrong. That's important to understand, that if something is proven wrong, that's a one-time thing. But we don't prove anything, because if I ever know anything for sure, if I ever reach a level in my knowledge that cannot be changed, then at that instance, science has ceased to exist. So it's important that we understand that science isn't perfect. We don't prove anything in science. Really important along the same lines to understand that science, a lot of people say this. You may have heard it before. Science was created by God. That's not true. If there is a God, and I believe there is, if there is a God who created the universe, science was not created by him. I'm going to talk about in just a minute what science's job is, but science is a human creation. It's a human endeavor. We created science in order to explain this world that has been created by a higher being, if you believe in a higher being. Whether you believe in a higher being or not, science is a human endeavor. We created the process. It's a good process. But the question at the end, are humans perfect? Of course not. Science is not perfect because humans are not perfect. Unfortunately, there are many examples that can be cited of scientists who allowed their own opinions and presuppositions to come into their work, and they misrepresented science. In some cases purposefully. And that's an unfortunate event because it makes science look bad. So just because one scientist did it wrong doesn't mean science is bad, but science is a human endeavor. Anything that is taken on by humans is going to be imperfect. The third thing science is not is it is not subjective. Certain rules and procedures have to be followed to be called science. So in order to do science, in order to call something science, I've got to take a certain process into consideration. I can't just decide on my own that I think this is what is going on or that I think this is the explanation of it. And we can break this down in very simple terms. If you get up in the morning and your car doesn't start, a subjective measure would be to say, well, I think it's the battery. But that's subjective because you've done absolutely nothing to actually determine if that's the case. But if we open the hood and do some tests, that's a process that we call science, which is objective, not subjective. In other words, in science, nobody's opinions matter. It's important that we understand that we check our opinions at the door and we just look at the facts that we have and we try to impartially evaluate them.